Okay, at 11.5 here, we're going to look at vapor pressure. Okay, and so we're going to examine exactly what vapor pressure is. And we had mentioned before and that it deals with the pressure that a vapor exerts over a liquid. So let's look a little bit closer here now exactly as to what vapor pressure is. Okay, so as a liquid is heating, your vapor molecules begin to form. And as they begin to form then, you're going to have a vapor pressure that's going to start to increase because you have more and more and more gas particles over your liquid. Okay, but you also have to notice, okay, keep in mind that some of your gas particles are going to get recaptured and become a liquid when they hit the surface of the water or surface of the liquid. Okay, after a short time, the particles that are leaving the liquid will start to equal the gas particles entering the liquid. Okay, this is when then your vapor pressure, the pressure over your gas, or the pressure over your liquid becomes constant, and we call that dynamic equilibrium. Okay, and you see in the picture, all right, that you have this liquid ethanol, and then after a while, the pressure of my gas is what we call equilibrium vapor pressure, where molecules enter and leave the liquid at the same exact rate. And we'll look more into equilibrium later on. Okay? Now at some point, molecules on the surface of your liquid possess sufficient kinetic energy to overcome the attractive forces of their neighbors, and they overcome the attractive forces of their neighbors and escape into the gas phase. Okay? But not all particles have the same kinetic energy, so only a few have enough energy to enter the gas phase from the liquid. All right. Now, the weaker the intermolecular forces, the higher the vapor pressure, because it's a lot easier for these gas particles to form, because it's a lot easier to separate or sever my liquid intermolecular forces. All right, now volatility goes along with this, and temperature. Okay, vaporization occurring in an open container allows the vapor to spread away from the liquid, so little to, if any, of the liquid is recaptured once it is a vapor. This means that equilibrium is never occurs, and vapor will always continue to form until my liquid is gone. Okay, substances with high vapor pressures will evaporate more quickly, and these are called volatile. Okay, so this vaporization in an open container is going to be like if you have a pot of water that's boiling without the lid on top. Now, you're not recapturing that vapor at all, so that's just going to continue to go and go and go. Okay, we call very volatile substances are also ones that tend to evaporate or vaporize very easily because you're going to smell them very distinctly. Okay, we have here where it says hot water evaporates more quickly than cold water, because your vapor pressure increases with increasing temperature. Okay, your molecules move more energetically with a higher temperature, therefore they can more readily escape their neighbors. Okay, so hot water has a lot more energy, so my vapor pressure is going to shoot up right away because you're going to have lots and lots of water molecules that can become gases, and so I'm going to have lots of pressure over top of my liquid. We have a higher vapor pressure. Okay. Now we talked about with vapor pressures and boiling points that something boils, okay, when your vapor pressure is equal to your atmospheric pressure. Now be careful, we talked about this last year, that a normal boiling point, okay, is at 1 atmosphere. And that's just with a normal. There are many boiling points. Okay? A boiling point is any time that they are equal. So if you change your atmospheric pressure, you change your boiling point for things. Okay? And if we look here at an example, all right, we have water. Now at 760 torrs, it's going to vaporize at 100 degrees. But if we have a vapor pressure, okay, or an atmospheric pressure of, say, closer to 400, then it's going to boil at around 80-some degrees. So you've got to be very careful as to when or what your atmospheric pressure is. So if atmospheric pressure changes, then your boiling point changes. Okay? And the temperature at which a liquid boils increases with increasing pressure. And you've got to be very careful with boiling points in cooking. Okay? The max temperature of the food being cooked in water is the boiling point of water. Now, if you're at a higher altitude, okay, that's going to be a lower atmospheric pressure, which means it's going to boil sooner, which means you're going to have a lower boiling point, which means that it's not going to reach as high of a temperature, which means it's going to take longer to cook. So practice problems here. Using that figure 11.24, which is just the figure we looked at with the increasing lines, okay, estimate the boiling point of diethyl ether under the external pressure of 0.8. So if we look here, we've got diethyl ether. Okay, we've got an atmospheric pressure of 0.8, so figure out about how many torrs that would be. Okay, well this is one torr. When we look for 0.8, we're going to end up getting about, here in the middle, about maybe 27, 30, okay, 30 degrees Celsius. And it says, at what external pressure is ethanol going to have a boiling point of 60? So I've got ethanol. I want a boiling point of 60 degrees, so I find my 60 degrees. It'll boil at 60 degrees. If it's somewhere, I don't know, I'd say maybe 375, okay, or 350, torr.